What if I told you that NASA once built a fully functional nuclear rocket engine, powerful enough to take humans to Mars, and then just shut it down? A rocket that could have fundamentally changed the future of space travel. A ship that promised to unlock the solar system, and then vanished into the dust of the Nevada desert. This is the incredible untold story of Project NERVA, NASA's nuclear spaceship that never flew. Before Elon Musk, before Starship, before the Artemis missions. There was a dream of an atomic spaceship, fueled not by fire, but by the very power of the atom. Let's journey back to a time when NASA dared to fly with nuclear power. The 1950s were the dawn of the atomic age. The world had just witnessed the terrifying power of the atom and was convinced it could be harnessed for anything. People imagined nuclear-powered cars, atomic airplanes, and even cities under domes on the moon. Scientists posed a logical question. If nuclear power can keep a submarine underwater for months without refueling, why not use it for rockets? The problem with chemical rockets was, and still is, obvious. They're incredibly powerful, but wildly inefficient. To get to Mars, you need a colossal amount of fuel, and most of that fuel is just used to push more fuel. But a nuclear thermal rocket? That changes the entire equation. Here's the genius of how it worked. Inside a NERVA engine, a compact nuclear reactor would heat liquid hydrogen to an astonishing 2,500 degrees Celsius. This superheated gas would then expand violently and shoot out through a nozzle, generating immense thrust. There's no combustion, no need for heavy oxygen tanks, just pure, raw atomic heat. The result? An engine with twice the efficiency of the best chemical rockets. That means you can carry less fuel and more payload and slash travel times. It was the holy grail of deep space propulsion. NASA called this concept nuclear thermal propulsion, or NTP, and the first program to test it was codenamed Project Rover. In 1955, deep in the New Mexico desert, scientists at Los Alamos began experimenting with nuclear rocket designs under Project Rover. They built a series of small, strange reactors with names like Kiwi and Phoebus, experimental beasts designed to push the very limits of what was possible with nuclear heat. When the first Kiwi test engine roared to life in 1959, the scientists watched in awe. They were, quite literally, containing a small star right there in the desert. By the mid-60s, the technology had matured significantly. NASA joined forces with the Atomic Energy Commission to create the next evolution, a full-scale, flight-ready engine. They called it Project NERVA, the nuclear engine for rocket vehicle application. NERVA wasn't just another experiment. It was designed to be the future of spaceflight. The engines were built and tested at the Nevada test site, where massive concrete stands held the reactors during firing. When ignited, the engines glowed white-hot, belching a plume of superheated hydrogen as a thunderous roar echoed across the desert landscape. These tests proved something extraordinary. A nuclear rocket could run safely, be restarted multiple times, and produce thrust powerful enough to launch a massive spacecraft all the way to Mars. NASA even started designing full missions around it. There were detailed sketches of NERVA-powered Mars ships, and even plans to replace the upper stage of the mighty Saturn V with a nuclear engine. The ultimate goal was to land a crewed mission on Mars by 1981. Just imagine that. Astronauts walking on the red planet in the early 80s. With NERVA, the vastness of space suddenly felt within our grasp. Missions to Mars would take half the time, drastically reducing the crew's exposure to cosmic radiation and lightening the load for life support systems. Nuclear power could even sustain orbital habitats or permanent bases on the moon. In a 1969 presentation to Congress, NASA's administrator described a new nuclear space age, complete with fleets of atomic ships exploring the solar system. The technology was proven. The science was sound. The dream was alive. But then, it all just stopped. By the early 1970s, the political climate in America had shifted. The Vietnam War was draining the national budget. The triumphant Apollo program was winding down, and with the race to the moon won. public enthusiasm for costly space exploration was fading. On top of that, a growing environmental movement raised concerns about radiation, nuclear waste, and the potential for fallout. And then, in 1972, President Nixon officially canceled Project NERVA. Just like that, NASA's nuclear ambitions were shelved. The test stands in the desert went silent. Over $1 billion and nearly 2 decades of groundbreaking research were abandoned. The engineers who poured their lives into the project were heartbroken. As one of them famously said, "We built the engine that could take us to Mars, and no one wanted to go." But NERVA's story didn't truly end there. Its technology remains one of NASA's greatest what-ifs. Modern programs, like DARPA's Draco project and NASA's own Mars mission concepts, still rely on the same fundamental nuclear thermal principles first proven by NERVA all those years ago. Even today, it's considered the most realistic path for sending humans to Mars quickly and safely. Some of NERVA's test engines still lie buried beneath the Nevada desert, silent monuments to a future that came too soon. If NERVA had flown, our reality might look very different today. We could have nuclear-powered shuttles making regular trips between Earth and Mars. We might have permanent lunar outposts, and a human civilization actively reaching outward across the solar system. Instead, NERVA became a ghost, a haunting relic of what could have been. But as NASA and private companies once again set their sights on Mars, that ghost is beginning to stir. Because the future we once imagined may yet rise from the desert dust. This was the story of NASA's nuclear spaceship that never flew. The dream didn't die. It's just been waiting for ignition. If you enjoyed this deep dive into forgotten space history, hit that like button, subscribe for more, and let's continue to explore the incredible stories of technology that was ahead of its time.